It takes 81 trillion BTUs of energy every day just to warm the ground here at Kern. Enough energy to power one large air conditioner for every human being on the planet. In Alaska, BP hopes that a similar technique will help save Prudhoe Bay. They're building giant heaters to warm and soften heavy oil, which is otherwise too thick to recover. Warming oil in the Arctic is no easy trick, but BP hopes it will keep Prudhoe producing for years to come. The difficulty of extracting oil from old fields around the world makes ANWR an appealing target. Over the past century, oil exploration has touched nearly every corner of the globe.
There's not a lot of easy oil left to be found, otherwise we would have found it, and that's what we would be targeting. You know, right now we're pushing out to more remote areas, we're pushing out to deeper water, whether it's Gulf of Mexico or even offshore Alaska, and continually looking for larger accumulations.
In the Gulf of Mexico, they produce twice as much oil as on Alaska's North Slope. And there's little close to shore that remains untapped. So companies are going further than ever before.
Discover Deep Seas, Discover Deep Seas, Chevron 0 Charlie Victor.
Deep Seas, go ahead.
Nearly 100 miles offshore, this ship is drilling one of the deepest holes ever drilled in the Gulf of Mexico. Chevron is drilling down more than 5 miles, as deep as Mount Everest is tall, all to look for oil that might be hidden in 7-million-year-old rocks.
Y'all ain't got nothing for Bob Joe going on, get him down there.
Reaching such a small target from 5 miles away is the equivalent of hitting the pitcher's mound in Yankee Stadium from an airplane circling 30,000 feet above.
This is where the extreme limits of oil exploration are taking place. Technologies are cutting edge. We are looking in places that we've never looked before. I have high expectations that what we're drilling are going to be successful, but not every time are we successful.
Until recently, this would have been technologically impossible. But the Deep Seas is armed with the newest technology. Submarines can monitor well placement, even 10,000 feet below. And rock samples from the bottom allow scientists to analyze exactly what they're drilling through and where they are in geologic history. Every hour, new samples are brought from the drill room to an onboard geologist and paleontologist.
The sample catchers are catching drill cuttings every 30 feet. So I check them for oil shows and make sure that we understand the rocks that we've been drilling.
But it's not just rocks that appear from the deep. They're searching for carbon-rich plankton that died millions of years ago and were compressed into oil. Finding skeletons like this can mean oil is close by. But Chevron's not saying yet what they found at this test well. It has only a 1 in 5 chance of going into production and costs up to $100 million to drill. With stakes this high, it's what's referred to as a tight hole.
A tight hole is a well that we have drilled where we're not saying anything about what we found. We're not saying whether we found anything. We're not saying we didn't find anything. But a tight hole is information we pretty much keep to ourselves. because this is a highly competitive industry. It is like a poker game. It is very high risk.
Spending on oil exploration and development in the U.S. has tripled in recent years. But America's production of crude is at its lowest point since 1949.